So this is basically the second part of chapter 4. Okay. I am looking at the file razors and blades. Blades and no blades are the two worksheets down here you can see. So last week we were looking at this example here, the no blades example, meaning we looked at this exercise where we had to find the best price so we can maximize our profits for razors. Okay, so in this example, the product we're interested in is razors, and we were, just so we can remember this, let's make this a little bigger again. So we were looking at first of all what the demand curve looks like for this product. And let's remember, we were given the data that the price is 5, right? Demand is 6. So whenever, that means whenever our price is $5, we're assuming here that we're selling 6,000, I think is the units here we're omitting. Yeah, so let's say 6,000 or millions, I believe, 6 million razors. And we're also given that the elasticity here is 2, right? That's also what I mentioned last time as well. It's not given in the files that come with the exercises in the book, but it is explained there, right? So we want to make sure we see it here, that the elasticity, the price elasticity of demand, so I just write elasticity here, that it is 2. So based on this, we get the second point here. So we calculate that if right now our price is 5 and the demand is 6, then if we increase our price by 1%, so it becomes 5.05, then the demand will decrease by 2%. So it will become 2.88. And we saw different ways in which we can calculate that. Just different ways in which basically you can write out the formula, but the end result is always 5.88 when your elasticity is 2. So based on this, now we can, using these two coordinates, right? These two pairs of data, we can just insert a scatter plot, right? That is, and this is called a scatter chart in Excel. So we can create this based on that, make sure the data is selected appropriately, and then all we need to do is see the trend line here, make sure it's linear. Again, this is our assumption here, right? Along with this, that it is a linear demand. And we are given this equation for that line, right? 2 points, unique line goes through them. That is the equation for that line, all by using this trend line option here in Excel, okay? We just make sure it is linear and we display the equation on the chart. So this gives us the equation basically for consumer demand for this product, razors in this case. So we saw all that last time, and then we also saw how we can use this. Now we have this equation for demand, and we can use it to help us find the best price by incorporating it in our profit calculation. All right. So we said our profit should be what? The demand times price minus unit cost. I have this right here. So basically, to create that, just so we can remember and maybe understand it a little bit better, to create the calculation for the profit, we just basically typed out that formula to include this thing here, all right? To include what this equation shows us here, which is basically that in order to find our overall profit, all we need to do is basically just find out the unit profit times the demand, which is, if you think about it, how much profit we get per item, right? Times how many items we are expecting to sell. So this will give us profit per item times items, right? So it's our overall total profit. So if we want to translate that, right, to write the formula, that would be if P is our price, and we can say unit cost, right? That is the cost per product. The price per product minus the cost per product would be the profit per product or per unit, right? So unit price minus unit cost will give us the profit per unit. So if we just multiply that by the number of units, so the demand, and one way we can write that is D of P, right? So the demand for that price point. This is how your book writes it, or you can just say, the demand. Then we get our profit, right? And based on this, we calculate our profit here, right? Demand, it's on this side now, times price minus unit cost. So where did we find these? You see how they're all colored nicely, right? So you can see here demand is on this cell, price is here, unit cost is here, and we're using those names, remember, because we just named these cells here, demand. We could just as easily have said equals the demand. So this cell here, but because it's named, it already says demand, right? So we could have said, so let's say we just say the demand was here. I'm just writing them again here, right? So we could have just as easily said, okay, this is equal to demand here times profit per unit, which is price per unit minus cost per unit, unit cost. That's the same thing, right? In one case, you didn't name the cells. In the other one, you did. So this is easier. All you have to do is just name the cell, or you can select them all. Name manager, actually create from selection. And then you just say the names are on the left column and these are created. Okay. Of course, this has been done here and we already have them here. So whether you name them or not, this is how you calculate, how you type out the formula for the profit, right? So looking at the names helps us understand it and figure out what we are calculating where better, easier, right? So here we calculate the profit. Here is our demand. So how do we find this demand? Let's remember again, we just did all this, right? The first step was to find everything here in this equation. That is why we basically did all that, so we can type out here the calculation for the demand. So we just write this equation, right? What is it? Y equals this, meaning the demand, because demand is our Y here, is equal to this, and our X is our price, right? So all we do is 18 minus 2.4 times the price. X is our price. We named it price here, remember? So that's pretty easy. Or we could have just said is equal to 18, it was, minus 2.4. And these are the two coefficients we got from here, right? Times price, either like this or like that when it's named. And this is our placeholder for the price. And this is our unit cost, which again, it's part of what we know already about the situation. We know that our unit cost is $2. So to see it in a different way, these are all given. We were given the fact that it's a linear demand, that we were at a price point of $5, and this is the units demanded, that our price elasticity is 2, and the unit cost is $2. So we found this, we calculated this to find the demand, right? And we also calculated the profit. So just by having this, say this will be our price, and we can, let's say, put the 5 here. This is just a value we start with. It's a starting point. So the final step after we set all this up is to use Solver, right? And again, all of this we did last time, but I'm just recapping here. So how do we use Solver? We go to Data. And here we have the Solver, which, remember, we went to options down here, and we found the add-ins, and we want to make sure it's part of our active add-ins. If it's not up here, you find the place where it says manage add-ins, go make sure it's checked. The Solver and the analysis tool pack we've used in the past, and we will use again for regression. So make sure those two are checked, okay, and this will make this Solver option appear here. So we go to Solver here, and because it's already been solved, it's already populated here, but of course we would need to go ahead and say what we're trying to do, okay? So what we are asking Solver to do for us is to find what was the initial question, the profit maximizing price, right? That's what we're looking for. So we are changing the price, trying different prices out so that we can maximize our profit. All right. So the objective is profit needs to be maximized. So we have selected max here because we're maximizing the profit by changing the price, right? Trying multiple values for the price. When this, so basically Excel tries and sees what happens when this is $1, right? When this is 1, what happens? When this is 2, what happens? When this is 5, what happens, right? And solve, okay. And then it figures out that when this is 4.75, actually 7499999 and some other digits, basically 475, then the profit is 18.15, and you could even see more decimals if you wanted. Well, in this case, that's all. And then our profit is the highest it can be. So all that Solver does in this case is just try what happens when this is 1. Notice this is basically, to do a number, right? -15. This has been formatted. When this is $2, when this is, oh, I guess we cannot define that. When this is 3, when this is 4, when this is 5, when this is 4.43. It tries all these different possibilities here. And then it figures out that, you know what, 4.7 gives me a quite high number. 4.8 also gives a high number. So then it tries numbers in between there. It tries different numbers, much higher, much lower. When it sees that the profit looks to be high, tries numbers near that area, and then it figures out in the end that the best one was 4.75 or something, right? Well, let's try it again. So maximize profit by changing price. That's all we did there. And we said solving method. The default is this one, GRG nonlinear. That's the one we use here. You will see this one is the most common, and also the evolutionary. This is basically one we will use later on. It is an option you use when you have cells here that are included in the calculation that change non-linearly in specific intervals. Basically, when you use uh, countifs, sumifs, and even ifs to calculate these cells, the evolutionary is most likely the best one. But anyway, here we're using this one, GRG nonlinear, because all we're doing here is applying just and solve, right? Okay. We're just applying basic mathematical operations, subtraction and multiplication, right? Or division would also, all of these basic operations are included here in the cells that change so we can calculate this, right? So that is what we need to choose here. Any questions on how all this works? So let's take it one step further, all right? So you might have noticed, as I said in the beginning, this is called no blades, and we also have blades here. So let's see what happens when we look at incorporating blades. Blades for the razors, that is, okay? This is our product here. So what happens in this case? Well, all right, so I guess we can start from this sheet. So this is the case where you don't only consider what happens with your profits just based on the price of one product. This is what you do in the case where you want to consider complementary products or product tie-ins, meaning things don't happen in a vacuum, right? In the marketplace. And many times a company might sell not only one product, you don't only sell razors just by themselves, right? Chances are you're also selling perhaps blade replacements for your razors, cartridges, right? Or for other types of products, it could be um, the typical example is, printers with their cartridges, whether it's the ink or the toner, right? Or when you sell different kinds of complementary products. So like the exercise that you will have for homework, it's mostly, I think both questions are looking at uh, an example where the product is a video game console, right? But if you're selling a video game console, chances are you're also selling video games with it, right? You can't really use it and do much without the games themselves. So you have to consider not only what the best price is so that I can make the most profits out of uh, the razors or the video game console, but also how do I make the most profit out of the selling the razors as well as their blades, right? Selling the video game console as well as the games themselves. So in the example of the razors here, um, along with the information we had before, so all this, we know that the demand is linear, elasticity is 2. Um, Elasticity is 2, demand is linear. We know the unit cost is $2. We also consider the fact that we want to uh, we want to see what happens when we take blades into account. So we know that each of our customers that buys a razor also will buy 50 blades over the course of their the lifetime of the razor. Okay, and we also know, and in this case we're just taking a set profit per blade of 15 cents, meaning we know that every time we sell a blade, we make 15 cents, all right? The replacement blade. So we will take all of this into account in this case, all right? How does that change any of our calculations? It doesn't change most of it, only basically the last couple steps. So you still you still need to have, because this is a linear demand, these there's 2 points here. Or if it's a different kind of demand, it doesn't matter. You still need to find an equation for your demand. In this case, this is the exact same data, so it's the exact same demand we just found. So that is how you type it here, right? 18 minus 2.4 times the price. That's same as before. Your price can be, you also need to have a place for the price here to include in your calculations. Let's say here, let's put 5, right? That is our starting point. Or you could start from 4.75, which was the result of this calculation, right? But we just need to include these 2 additional pieces of information. So how do we incorporate them here? Everything until here is the same. I think I have this typed here, yeah. So we just need to basically understand that the new equation for our profit will be this. All right. So before, we just considered the profit that comes from razors themselves. All right. That was, let's see, the red part here. Okay. Is this visible? So our profit before just include the profit from the razors, demand times price minus the unit cost for razors. That's fine. Now, if we consider the profit for the whole product, let's say the pair of products, which is a good idea to do, right? Because we said consumers use them together. So it makes sense to include that. All we need to do is add this additional part here, right? After the plus sign, which is the profit that comes from the blades. So we could say, okay, let's say we have blades per razor and profit per blade, right? This is the additional information we have here. Blades per razor, 50, times the profit per blade, 15 cents. One times the other is the profit. So the profit from all the blade sales. All right. It's basically the same as this. Demand, this is demand for razors. Blades per razor is basically just the demand for blades. We could also have called it demand for blades, but because we're not really calculating this right now, and we just take the number as a given, the 50 razors, we just can say blades per razor. And the profit per blade. And notice how these here have these colors. Everything has a color here. Notice how they all refer back to all these cells. And of course, in this case, we have also named all of these. So the easy way to do that is just select all these cells before you even make any calculation, you just need to have this data that's given, placeholder for the price, or type out this equation. At some point, you can type that out, but you need to select all that, formulas, create from selection, make sure you have checked where the names are, right? The left column, and the values are on the right. So that Excel automatically basically names each cell on the right as whatever is typed on the cell on the left, right? That's all we're doing here. So this is, notice here, unit cost. This is blades per razor. So now when we type it out by name, everything is included here. And again, the same as in the example with no blades, you can always just refer to the cells themselves. But this is tidier, right? And even if we move this elsewhere, or like we copy this elsewhere, it still will be looking at the same thing. Right, so we just added one more thing basically to this calculation, and these numbers do not change. The only thing that still varies is the price for the razors, right? This is what we're trying to figure out. So instead of finding the example with no blades, we were looking for the price that gives us the most profit out of razor sales. In this case, we're looking for the price for razors that gives us the most profit out of razor and blade sales. All right. How did we incorporate that? Just adjusting our profit equation. So now we can just run our solver. Again, we are looking at maximizing this profit here by changing the price. Profit is maximized, right, by changing the price. Solve. And again, we get this little box here, the pop-up. Okay, keep the solution. The price is $1 here. Notice that. Here it said 475. Demand would be 6.6. Profit would be this, 18 million plus. But if you include the profits from razors and also how when you lower the price, you will increase the demand for razors, increasing the demand for blades and the overall profits from the blades. So incorporating all of that, you see that the best price here is just $1, so that we have a much higher demand, both for razors and for the blades implicitly, right? And then our overall profit in this case is $101 million in this case, right? 109.4. When we calculate both. All right, any questions? So that is basically how we incorporate those complementary products, add-in products. And finally, so if we have no questions here, finally I want to look at the last case we will see here, which is, well, here in this chapstick price file, which basically looks at what happens when your demand might not be necessarily a linear demand or a power demand based on a power curve. Maybe it's something else. Maybe you don't really know what it is, all right? So in that case, what you can do is follow this method right here, all right? Again, this is when you don't really know, you're not really sure about your demand curve equation, what it necessarily should look like. So you want to be more flexible about it. But in order to do that, you need to have 3 points, all right? You need to have 3 combinations of price and demand information. And using those three data points, you can basically again use the scatter chart and the trend line tool for from Excel here, but introduce instead of a linear, you introduce a polynomial here line. All right, but it's the same principle, right? Starting from, let's say you have a product, I guess in this case it's a chapstick, all right? And you know that if you sell it for $1.50, you will, you expect to sell 60 of them, 60 million or whatever this is. Let's say 60,000. If you sell it for, I think this is like 60,000 in a week or something. Let's say you sell it for $2, then you will sell 51,000. If you sell it for $2.50, you will sell, of course, fewer, and that would be 20. All right. This could be information that is based on past experience, past sales, or it could come from experiments, perhaps. In any case, you know that number one, when you charge these prices, these are the equivalent demand points. This is how much you expect to sell. Number two, you know, and this is very important in this case, when we use this method, you know that the price will not be less than this or more than this. All right. These are basically the two boundaries, the two extremes you're imposing on your price. Okay. Because you know you want to price it around this range. Okay. So knowing this, we can first find the equation demand, right? So in this case, as I said, we want to have something more flexible. So what we want to do is insert a chart, right? The scatter chart. Make sure the data is shown correctly. So the price is on the x-axis, the quantity, the demand is on the y. Okay, that looks good, right? And all we need to do is just right click here on the series on the point, add trend line. Remember, whenever we click that, Excel automatically, right, gives us the linear line here, the linear curve. So we want to select here a polynomial, all right, of order 2, meaning, because we have 3 points, right? Meaning we want to fit this quadratic equation, right? And let's see display equation and chart as well, the same as they did with the linear. Let's make this bigger so we can see it. And this is it, okay? And notice here, this has an error. We don't want to see our square. This is not any kind of least squares estimation. This is just plotting this curve, all right? Which is our demand curve in this case. There is no random estimation. So we just have to see the equation. Oop. Here. Need to make sure we have selected the display equation and chart. And notice we just have 3 coefficients here instead of 2, because this is a quadratic equation, so we have x squared and x. And that is about it, that's all. It's just that the equation is a little longer, one more coefficient, but nothing that changes anything else that we did so far, at least not in terms of the demand. Okay, the demand estimation. So again, like before, because we want to find the profit, and the profit is demand times price minus unit cost, we have this we type it out here in one cell. This cell will uh, have the price. So we just type out this demand that we just found here in a cell, right? That we assign to demand. We name it as demand, right? So all we need to do is just basically type what is written in the equation. So negative 44 times x squared, x is our price, right? So negative 44 times price raised to the power 2 plus 136 times price minus 45, right? It doesn't matter the order you type them out. In this case, we follow this order, so we make sure everything is correct. And that is um, how we find, oops, our price, okay? I'm sorry, our demand. Our price is here. I was just typing here, let's say a 2, which is the medium point here. So we can just go ahead and ask solver to find the best price, which in this case is right here. This is price, or I can type out price. Because as before, we need to have named these. So selecting them and create from selection, or just select each one and type the name here. It doesn't matter. We just need to make sure they're named. So we can just go ahead and ask solver to, as I was just saying, maximize profit by changing price. Now, in this case, there is we need to include some constraints, and this is basically what this area here that we've been seeing before, and you might have wondered, what is all these things here? What do they do? So this is where these options come in, all right? As I mentioned when I described this, problem here, we said that we have this information, right? And we know that our price should be anywhere between these two values. So it should be within those two boundaries. So that's what all we need to tell Excel. You know what? You need to try different prices between those 2 points. I don't want you to try to see what happens if price is $1 or if price is $2. Sorry, $3, right? It has to be, or 2.6. It has to be anywhere from 1.5 to $2.5. So this is what we have typed here. So how do we do that? Basically, we say add. Okay, so you add a constraint. So cell reference. This cell, so right here, not this one, the one we actually included in our calculations, the price. Or you can type price. Should be what? Should be greater than equal to $1.50. So we can type it out, or we can include this cell. Let's type it out for ease for now. Okay. If you press OK, this inserts it. Let's say OK. So you see it's added here. It's the same as this. We just added it again. And then again, we want our price, which is basically this cell, to be less than or equal to 250. So when you think about the constraints, make sure you double check your less than or greater than, so you don't do the other way around. Sometimes we might overlook that, okay? So these are the same. So if you have additional or you make a mistake, you can delete them. So I'm deleting the duplicates here that were there from before, from earlier. And if you make a mistake or whatnot, you can click change and go adjust if you made a typo. Okay. Or if you want to add multiple at the time, you can type out things here and say add. Oh, see, now it knows I'm playing around. You can say whatever, this, add. So when you click add, it's just gives you the option to add more before you see them. Uh, Now, of course, I'm going to delete these random things. And I'm keeping the constraints I actually want here, right? Price, let's double check, greater than or equal to 1.5 and also less than or equal to 2.5. Yes, between those two. And the rest is all the same. That's the only change here. And again, that's because that is part of our problem in this case, right? It needs to be between those two values, the price that is. So just solve. Okay. Sometimes solver, when you say solve and you have multiple files open, it can go back to some other file you were working on. So that happened just now. But it did solve it. And it said that, you know what? The best price is $2.04. At that point, your demand will be, at that price point, your demand will be 40, this number here, right? 49,000, we said, units. And your profit will be $56.24,000. Okay. And if we also see, let's say if the price was 2, uh, the demand would be higher, right? So instead of 49, it's 51, but the profit is a little lower. If the price was 2.1, so I'm trying to 2 points that are close, right? Close to the solution. Then the demand will be a little lower and the profit also is a little lower. So this is the best profit, the highest profit, right? Any questions? That is basically how you find this, the profit maximizing price. Again, this is uh, the same problem that we're trying to solve in any case, finding the price that maximizes our profits, but the conditions are different. We saw what happens when you have a linear demand, what happens when you have a power demand, what happens when you have an unknown or undefined demand, and 3 points of data, right? You need to know that. So in this case also, we don't know the price elasticity when we don't need it, all right? For the other two, we needed the price elasticity. For this one, we don't. But we need to provide boundaries for this to work. Otherwise, it might going outside of those reasonable boundaries can give you invalid results, okay? Results that might be weird. Okay, any questions on this? All right. So I guess that's it for the price and the pricing chapter. All right.